So this is the IBM SPSS Modeler Software that forms a core component of the Predictive Operational Analytics application template. And we use this software because by doing so we're able to read many different forms of data and transform them and consolidate them and prepare the data for modeling purposes. The modeling itself might consist of building a predictive model to predict likelihood of failure. It may consist of finding associations or correlations from the data. It may be used to identify anomalies or similar behavior in particular types of equipment or assets. There's a lot of different sorts of analytics we can bring to bear before we finally assess that analytics and send the results of the analysis process back out to a operational system such as workforce management or business intelligence or management information tool. So the example that we've got here is from sales side maintenance, and I'm just going to click to open up what's called a modeler stream. And in Modeler, what we do is we drag together these different objects, these different icons or nodes as they are known, in order to create a process that enables us to build a model. And in this case, I'm just going to give you an overview of the data. So we've got some data here just sitting in an Excel spreadsheet. It might be in text format, it might have been in a database. It may well be that the data originally begins in many different formats and we consolidate it in Modeler, but to make it simpler, we've just got it in one file here. If I show you what the results of that look like when we browse the data, you can see that it's made up of 27 fields currently and 3,427 records. And what we have is an incident ID. This is an ID that refers to an error or a fault that's been detected or a problem that requires inspection. We have a date of the error. We have the location code of where that asset is. We have the month it was created in, whether or not it fell within the weekend, the region type, whether or not that required another visit within 20 days, number of days until the next fix, the days since the previous fix. Then a flag here that indicates whether or not that site had a high error count, the error count within the last 12 months, and then some information about competing tasks in the same area in the same week to give an idea of, how busy the engineers were. We've got information about the antenna height, whether or not it was a GSM or UMTS protocol that was being used, the site technology, the primary site technology has been used there, which we've just called Series 1 through the Series 4. The 2G traffic and the 3G traffic, the field technician category, whether or not they were internal resource or a third party or a contractor, the equipment type, the activity, whether or not it was site related or hardware related, and the operator, which is the the company that actually owns the equipment that this maintenance organization is managing. So we've got one called Concord Blue and we've got one called Signal Red Inc. The site type coded whether or not it was a macro site or a microwave site, and then an error code. We'll come to those in more detail later, but basically each time a problem's detected, it throws an error code, and we have an engineer response. We can see what the engineers actually said when they've gone on to this. They've said FSME2 replaced as requested, job manager, and then there's a serial number there to indicate where on the job manager they can find that particular report. We have the error message itself, which varies as we can see, and we have the age of the Series 1 technology and the age of the Series 2 technology. It's 2G and 3G technology. Okay, so that's kind of what the data looks like. Just under 3,500 records, 27 fields. If we just give you an overview of the data here, I can show you it in what's called the data audit node, so you can see the minimum and maximum values, the months, whether the number of jobs in the weekend, the region type, and then days until next fix. This is quite a good way for us to assess the data, eyeball it, get a sense of the missing data in there, outliers and extremes, as is shown here is in the quality tab, where we can impute missing values, i.e. predict missing values, get an idea of how complete the data is, and we can do lots of stuff with regard to generating filters and forcing legitimate values and reporting on the general state of the data. If I just point to a couple of little specific fields here, we've got something called error message here, give you an idea of what the range of error messages are that we have. So if I click on that and then just sort it in order, you can see that you can have everything from pulse code modulation failure, which actually occurs twice because this is just a string field, so that's That's 10% and 3.41%. So it's about 14% of the time that's occurring. A very common error message is BTS operations and maintenance link failure, or WCDMA base station out of use. Just means basically the base station's not working at that point in time. But you can see some of them occur quite commonly. It's 664 times, and some of them occur very rarely, only once or twice. Transceiver fault, a perimeter alarm, mains break. So one of the things we might want to do is to look at this text data along with the text data in the engineer report and see if we can actually take this unstructured information and turn it into structured data to help us in our modeling tasks. You'll also see a little list here of the main error codes that we got, and I'm not going to give you a list of what every single one of them mean, but you can see that some of them, again, very variable. 7786 occurs 17% of the time, 7706 16% of the time, and those might refer to, for example, things like 7401 is a mains failure, 7402 is a rectifier failure, 7402 is load on DG, which is power failure, or 7600, which is the BCF faulty, temperature sensitive. That's because the BCF is quite temperature sensitive at that particular point. Okay, so one of the things we could do is we could begin modeling this process and trying to predict, among other things, sites that needed to be revisited within 20 days, or sites where a spare part was required or part replacement was required. But before we do that, what we can do is we can actually look at this free text data and begin the process of mining it in order to create new fields which might help us in the modeling process. So that's the next example we're going to look at. So we switch to a slightly different stream here, where we're really focusing upon trying to mine the text that refers to engineer response and the error message. So for this example, we'll just focus on the engineer response, and to refresh your memory, let's just have a look at that data. So here we have the engineer response. We can see that there's a range of different things they can talk about: battery replacement complete, no issues, or filter cleaned and checked okay on job manager, or private circuit fault, etc., etc. If I want to mine that, I can use the text analytics extension of Modeler to do so, and this will allow me to read free text in fields such as Excel files, or from customer reports such as call center logs, or error messages that have been generated and put in a database. There's a lot of different formats I can read it, but to show you what happens if I just run with the default settings, if I run the default settings just on this term, this field engineer response, we can see that what it's going to do is it's going to start mining that text and trying to pull out what it calls key concepts, which are words or phrases that occur within the text. And what we find is that, probably not terribly surprising, that the most commonly occurring concept is the concept type. And we have alarms. We also have phrases like National Control Center, or Union Telecom, or Clear Job Manager, or Restored Site, or BTS that's being mentioned here. So some of these terms are quite useful. Some of them possibly aren't so useful, such as the term fault, maybe, because most of them are referring to fault. Error just really comes from the sites back up on our. But terms like reset, or loop, or rectifier, these really are referring to the that particular aspects of the job that the engineer's just done. So if we wanted to scroll down through this, we'll actually find that we see sometimes we get a concept which has actually been highlighted in a particular color, like Red Light Inc., which is an organization, or John Doe, who is a person, or Greenfield Inc., that sort of thing. So it's being picked up as an organization, so it can recognize certain terms and see that they are organizations. But as we would expect, we have to kind of help it along. Now, it's not essential that we do this, but it helps if we can start to gather together terms which are similar to each other. So for example, if I wanted to highlight the term rectifier, for example, and have it change that to a particular type from unknown to rectifier, I would go to the resource editor here, and I would go to the local library for this particular project and go to new type, and I'd say, okay, I want to create a type called rectifier, and I could give it a custom color here. Let's give it a red color, and I would associate the term rectifier and terms that refer to rectifiers or other types of equipment that falls under the same class. If I go for inflected terms, it'll look for plurals of that, etc., etc. If I go back to categories and concepts now, you can see that it's changed color. That's because I've updated the library in the background. If I rerun the extraction process at this point in time, we should find that when we scroll down through here, we'll find the term rectifier, and it's highlighted in red, and it's now falling into the concept rectifier. Well, it's actually not too difficult to do this with a lot of key terms, and we can obviously see which ones are coming out most commonly. So we can pick out key terms, we can find synonyms of those terms, and we can help the process along and create our own library. And in fact, just to show you what happens at the end of that process, after a few hours work, we can get to the point whereby, once again, our job is to look at these engineer response values here, these responses, and mine them. But this time I'm using what's called a pre-built package. So I've actually got a little package in here called engineer response, got TAP, text analytics package. If I run that, then we'll see that this time it's actually already got a series of categories I've created in the past. Some of these have been automatically created for me, some of them are created manually, but you can see there's an awful lot of color coding going on here, like alarms, reset, replaced, a Union Telecom, power, rectifier. So if I look at reset, for example, here, and click on display, it says reset to BCFA alarm. So we can see what's happening inside that. It's a reset. Our alarms is BCFA. We can see that it's reset and it's antenna related, or it's a reset, and there are AC, meaning air conditioning reset, so it's cooling related. So we can start to kind of categorize what things are related to that particular job. And it may well be that these categories that we're creating, if I then go and score the data and tell it and get it to tell me how many cases fall into these different buckets, that allows me to create what's called a text analytics model. And that text analytics model will then read any future piece of text that's relevant to that particular analysis and create categories for it. So for example, if I rerun this process using a previously built text analytics package here, and the resultant model, if I look at the data it produces, what we see is that we've now got all these different fields that have been created, which say fix alarms, fix antennae, fix audit related, fix BCFA. So I've given it the prefix fix because I know it's related to what the engineer did on site. And what I'm interested in is whether or not any of these things that the engineer did have a bearing upon, let's say, for example, whether or not the site has to be revisited again in 20 days, for example, or are there certain patterns related to the particular type of fault or length of time it takes to resolve that fault. I do exactly the same thing, of course, with the error message itself, and that may well help me anticipate what the engineer is going to do when they come on site. But for example, if I show the relationship between these different fields, I can do what's called a web plot. And the web plot here simply shows me strong relationships between certain types of things that the engineer has done. So we see the strong relationship between the term replaced, and rectifiers, and we can see slightly weaker relationships with SSME and cooling. So we know that rectifiers tend to get replaced. Alarms are very strongly associated with resets. Resets are also associated with the BCFA cards. So we can start to see situations here which are kind of interesting, because we know that the company is interested in when a part needs to be replaced, or when things are likely to just need a reset. And we can see situations where cooling's related to alarms, etc., etc. And we can control the strength of this relationship by going in and using a little slider control here and saying, actually, I'm only interested in really strong relationships, so just show me them and mask out the weaker relationships, or vice versa. I could look at the weakest relationships, masking out the strongest relationships, and so on. I can control the thresholds. Okay, having done that, what can I actually do with the data? Well, if I shut that down and I jump instead to the modeling part replacement here, Because I've created these additional fields and because I've mined the error message, I may be able to actually predict whether or not that job is going to result in a part being replaced. And that's what we're going to look at next.